Okay, so let's do question 9. You stuck on question 9. So let's have a look at the question 9. Explanation on questions 16 and 17 little bit. Then we will go. I feel that you guys like to have to do a quiz again here. So we will do a quiz. Okay. And then we will go to the future workshop, future week. Okay. So let's investigate. But the question 9. Again, I want to emphasize that please pay attention. So the due submission is like 22nd of August. So next week also, what until Friday? So when is the deadline of submission? What time? Until 27. 22nd. Okay, second. Yeah, all right, sorry. Couldn't catch. Until what time exactly? 12 noon or midnight? Okay, so next week we can talk about maybe your assignment, but I won't give the answer. Maybe hint. So then after this class, you can in a group you can talk about that. All right. So let M. Okay. I'm talking about question 9 of workshop. Okay. The adjacency matrix. All right. For the relation. Okay. In between, I will ask question. On the set. One, two, three, 4. Okay, you guys, are you listening? Okay, or you are hiding behind the monitor? Okay. Kate. Okay, pay attention here. I just said. I just said that. All right. So, and the other day I saw a student that he was my DTS student, first time, second time, and this year he's not in this class, but he's taking this course for the 3rd time. Because he doesn't pass. Okay. All right. So it's this one. So compute. I hope you did well during your yesterday quiz question, like not yesterday, this week in question 3. Compute M squared. Okay. So the adjacency. So we see that 1 is less than 2. 1 is less than 3, 1 is 4, less than 4. Okay, 2 less than 4, 3 less than 4. Okay, so what is the adjacency matrix? So let's call this 1, 2, 3, 4. It's because it's confusing with the numbers inside the matrix. Let's call them A, B, C, D. A, B, C, D. Can I move this? A, B, C, D. So what is A to A? What's this number? 0. What is A to B? A to A means 1 has relation with this. 1 is less than 1? No. Okay? I translate this by cross. Okay, so this means like it's not X, this one. Were you talking about this one? All right, okay. So now look at here. What is A to B? What's this one? What should I write here? What? Do you confirm? Here. Do you see the monitor there? So yeah, is it 1 or 0? All right. So 1 here, A to C. Okay. This one 1, 0, 0. Okay. 2, 1, 0, 0, 0, 1, 0, 0. Yeah, I was waiting to correct me. Okay, so I hope you were able to compute m squared. It was easy question 3, but yeah, hopefully you did that. Okay, so m squared was equal to m times m. So do you need an explanation again for this one? The dimension of the matrix is like 4 by 4, and the m squared will be also 4 by 4. So I think you don't need. So this one is 0, 0, 1, 2, 0, 0, 0, 2, 0, 0, 0, 0, 0, 0, 0, 0. Yes, is that right? Yeah. So this one is 1. Okay. So now let's go back here. First of all, what's the diagonal elements here? 0, 0, 0. So this means the matrix, the relation is not reflexive. Okay, it's not reflexive, not reflexive. Okay, is that symmetric? Symmetric. So matrix is not symmetric. Have a look at here. And matrix not only symmetric means, do you see this part, upper triangle part? It has to be, this is the mirror line, and it has to be reflected copy of the other side. It has to happen here as well. Okay, so the matrix is not symmetric. Also, okay, so you see this one, if it is symmetric, 1 less than 2 means 1 relation with 2, then has to be 2 relation with 1, means 2 less than 1, which is not correct. So it's not symmetric. Okay, now, not symmetric. Okay, it's anti-symmetric. Is it transitive? What did you conclude yesterday or this week? Is it transitive? Okay. So, do you see this one is 1 to 1? Okay. Non-zero parts are this, but where is here? It is the address of here 1 by 3. This one is 1 by 4. And this one is 2 by 4. Okay. So the same address, in the same address, it has to be non-zero as well. Okay. So all I wanna say, for example, if I see here non-zero, okay, and if I see here 0, then the matrix won't be, the relation won't be transitive. Why this happening? Why this is happening? So let's investigate. By the way, A, B, C, D, and also we have got C, we have got D. So there is another, so because of this one here, B to C, B to D. So just one example, there has to be an edge from B to, okay. All right, so now here, what is the meaning of transitive is like if A has a relation with B and B has a relation with C, then we see that here A has a relation as well with C. All right, B has a another one. A has a relation with C, has a relation with D, A has a relation with D. D has a relation with C, and C has a relation with D. B has a relation with D. Okay? Yeah. So this is transitive, but we want to understand from the matrix, and from the matrix, how do we check? M2, we will notice that we will have a look at the M squared, and we will see the non-zero numbers. If in the same place in adjacency matrix M power 1, it is also non-zero, then the matrix is transitive. If you see that like here is 0, but here is non-zero, there is nothing wrong with that. But if I see, for example, if this one was 0 and this would if this one was not 0, 5, 1, 2, and this was like 0, then the matrix is not transitive. So let's go into the detail a little bit. Okay, I want to remind you that this one. Very quickly. And this one here. Okay, so M2 I J is equal to, so later, do not say that you don't learn question 9. I'm explaining in the detail. Okay, so A, I, K, A, K, J. Okay, so all I wanna say is this one. M, 2, 1 by 4. Do you remember that this one is 2? Yeah, look at here. This 0, 2. Okay, here this is equal to K running from 1 to 4, A 1K, A K 4, A 1 1, A 1 4 plus A 1 2, A 2 4 plus A 1 3, A 3 4 plus A 1 4, A 4 4. Now look at here. Now let's show it by orange. This guy and this guy are 0. Well, so let's write this one. M times M equals, M times M was like 0, 1, 1, 1, 0, 0, 1, 1, 0, 0, 0, 1. Okay, here A14 is this guy, and A44 is this guy. And also A11 is this guy. A14 doesn't matter. So to understand this one properly, I hope I write here again. Okay, so look at here. For getting this one here, getting this one. So this means this times this guy. Okay, so this guy times to this one, this guy times to here, this guy times to here, times to here, this guy times to here. And you see that the only non-zero part, the non-zero part is this part and this part, which are this one. This one is equal to, so since it's equal to, we have got this one, A1, 2, A2, 4. These are 1, A1, 3, A3, 4 equals 1. From here, A1, 2 is 1, and A2, 4. To get 1, both of them has to be 1. A2, 4 is equal to 1. From here, A1, 3, A3, 4 equals 1. Now, from here, get this one, A has a relation with B and B, A2, A4. Okay? You want to see A24 is equal 1. This means A24 is here. 2, second row, fourth column. It's here. This means A, B, C. This is B and this is D. So this means B has a relation with D. Okay. And A13 is A has a relation with, any idea? A13 is equal to 1. A has a relation with C, and A, sorry, C has a relation with D. Okay. Now, you notice this one. Want to see that A relation with D. You want to see this one as well. A has a relation with D. Let me amend myself. This guy has to be C. But this one, A has a relation. Then once you have a look at the M2, then you will go back. Okay, so go back to the adjacency matrix, and you see that here, to confirm this one happens, once you look at the same place that it is non-zero, you go see here, you see that it is 1. And you also from A has a relation with R, you go and you see this one is confirming. Okay. So 2, what's the meaning of 2? This means from A, B, C, D, A, B, C, D. Okay. There is 2 paths, 2 possible paths from A to D. Okay. So you can see this graph as well. Instead of writing in this way, I have translated to the A, B, C, D here with length 2. Actually, if I said not 2 ways, actually there is way from A to D with the path 2. So one is this guy, and one is this A, C, and C to D. So it means that. So not like not 2 possible ways to go, because there's another from A to D as well. So this is just one example from 2. You can similarly you can do for 1 and 1, this one as well. All so for the last time I repeat, to understand that a matrix or relation is transitive, you will have a look at firstly M2 non-zero part, and you should confirm that those elements that are non-zero in the same place, it has to be non-zero in the adjacency matrix as well. Okay, so this triangle 1 to 1 is non-zero. This part has to be non-zero as well. That's all. Okay, so I hope this this helps you to deeply understand the. Okay. Question 16. I don't think you reached to this question 16 during your workshop. Question 16. Given an equivalence, um, on a set X, does this equivalence classes of R, there is a relation R on A on the set X, make or form a partition So the answer is yes. Okay. So this is the X. So it has equivalences A, and this one B, this one, and this C, D. So you see that first of all, according to the lecture notes, A, they are separate. Second, the union of the classes, S is a class, is equal to whole set. Okay. And vice versa. If you have any partition, you can claim that those partition is each partition is an equivalence class. Okay. So you can write the details. You need to write some details. Just to let you know that if you have classes A, B, if X belongs to class A intersection with class B, then we have got this one. Okay. So this is another thing that I wanted to share. Okay, now, what do you feel? Do you have a question about this week's workshop? It's important to, so I have not seen your assignment things like questions, but these things are important. Like, is your assignment like related to this week as well? Yes, no? You haven't seen your assignment questions? Is it related? Okay, next time, as previous week, I should lead you guys to sit like in front. Okay, all right. Next week, number theory. Okay. Okay, so since you guys are interested to do something, okay. Okay, I will make sure. I will make sure. Has to be included, right? Oh, this one we can pause. But okay. Make you forget. But for the second column of the same. First, second, what's the second column there? Second matrix. Where is the second column? Inner product. This times this plus this times this. Okay. Like for how much? One, 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 two, minus 1.3, so minus 1 side plus 2 times minus. But in this with this method, rather than this, you will remember 4 hours. Okay. All right. Catch up, please. We need to focus to learn this one today. Okay, just 1 minute. Okay, all right. Okay, before doing, now, I would like to go to next week, future week, and it's very important, that one. Before doing that, let's do this. Let's do this question 3. This quiz is just like extra things, like in few minutes, and I can give a feedback to your what you have learning, what you have learned. So from my understanding, I see that. Okay, I see that some of you have forgotten like the multiplication of matrices. Let's do this one. So I do some multiplication examples. So please, I'm pretty sure that you know that, but you had forgotten. So we do it now, and I will introduce almost like some way that probably you won't forget. So let's do this example. 1, 2, 3, 4 times 5, 6, 9, 1, -1, -3. Okay. What's the dimension of this one? What's the dimension of this matrix? The first matrix? What's the dimension of this matrix? What's this? Yeah, 2 by 2, 2 by 2. So it has got like 2 rows and 2 columns. Okay, so 2 by 2. What about second matrix? 2 by 3. Okay. All right. Let's see this one. So the answer of after multiplying, this will be so to be able to multiply two matrices, we cannot do this multiplication always. The column of the first matrix, this number, has to be the same as the number of the rows of the second matrix. This means like this number here has to be the same as this one. They cancel each other, and the new matrix will be some animal in the dimension of 2 times 3. Okay, so 2, 3, 1, 2, 3. So now have a look at here. So we know that to be able to get this guy, you times this one, inner product, this one. To get this one, you do this one and set this one. So again, this one and this one. Then you do this one. This one. This one. For this one, you do this one. This one. Okay. So it's you should remember this one. Okay, so but let's do differently. We see that this one the address of this one here is 2 by 2. This one is 1 by 3. This one is 2 by 3 because so 2 by 2 means this guy, this number here, this pink color here is in the second row. Listen to me. Second row and second column. Like that's why I have written here 2 by 2. This blue one, where is this one? What's the dimension of this blue one? Like which row is this one? Second row. And which column? First column? Yeah. So this one, 2 by 1. Okay. Second. So look, this blue is placed in the second row. Okay. We have first row, second row, and in the first column, second row. Okay. Second row and first column. Second row, first column. Is that okay now? Is that clear? Okay. Now, to get this one 2 by 1, 2 by 1, 2 by 1 means from first matrix and 2 by 1, 1 comes from second matrix. Okay, and first matrix, second row. Let me complete this one. Second row, and from second matrix, first column. Okay, let's do this one. Now, I want to obtain this one. 2 by 1, like second row is, so let's write here, 3 by 4. Inner product by first column, 5, comma, 1. So inner product 3 times 5, 4 times 1, plus 4 times 1. 15 plus 4 is 19. Okay? So how about this 2 by 3? I'm gonna do this one. 2 by 3. This is coming from first matrix, second row, 3, comma 4, inner product by third column. What's the third column in the second matrix? Second matrix, third column. I minus 3. You guys are you sure that? Are you with me? Yeah? Okay. So this one, 3 times 9, 27, plus 4 times minus 3 is minus 12. Adding them together is 15. So here will be 15 and here will be 19. Okay. But you know, I can do this one quickly. 1 times 5. Now 1 times 5, 2 times 1, 7. Now 1, 1, 2 times 6 minus 1. 1 times 6, 6. 2 times minus 1. 6 minus 2 is 4. 1, 2, 9, 3. 1 times 9 is 9. 2 times minus 3 is minus 6. It will be positive 3. So 2 by 2, 3, 4. Inner product by, guys, what should I, second column of the second matrix? X minus 1. Yeah. 3 times 18 plus negative 4 equals to 14. Okay. Hopefully you won't have problem about this one. So the question 3 is just finding m and finding m squared. So finding m easy and finding m squared by the method that multiplication and matrices is obvious. Next week you will have to, you should ask you will receive your workshop quiz, then you can complete your question. Now let's do this one. Now let's do time travel to the next week. Okay, so I do repeat that question 1 of the next week quiz will be about this one, this question. For question 3 of the next week quiz will be about this one as well. Question 2 is easy one. It will be about the graph theory. Now, next week in the workshop, you will have like, let me see. You will have 21 questions in the workshop, but most of the students just will challenge with this question. So it is better to learn right now. Okay. To solve this question, first of all, you learn number theory because of solving this question, and you learn these congruence equations. This is like congruence equation. So because you want to learn cipher function and decipher function. Cipher function to encrypting some data or message, and decipher function is like decoding or decrypting the message, because that's why you learned that one, because of that. Now, 27. Okay, I wanna, yes, please. Worksheet? No, we don't have worksheet of this one. No, worksheet, it will happen next week. Okay, so worksheets, I do have them, but I'm not allowed to share. And actually, right now, I should not talk about this, but yeah, I do talk. So next week, instead, in the workshop, you will have easy time. Okay, please concentrate and get part A. Okay, part A. To solve this question, 27x. Okay, now you guys, the repeated things finish. Please concentrate here. 27x equals 5 mod a big number, 125. Okay, to be able to claim that if this one, whether this equation has got a solution in the integer world, you need to check that the GCD of this coefficient number 27 and 125 can count this 5. In other words, 5 has to be divisible by the GCD of 27 and 125. All right. I want to depict a picture about this. So in the year 6 or 5, you have learned that. What's the answer of this one? 2. Because you just need 2 times this one by 1 over 5. 1 over 5x 10. So which is 2? The right hand side, x will be 2. But now here in the integer world, 27 doesn't have like inverse of, you need to find the inverse of the 27 in multiplication inverse of 27 in the world of the mod 125. It's not easy to find it. Now, so so we wanna let's have it. So at the first step, we quickly find the GCD of 125 and 27. And we have to do this one by the Euclidean algorithm. Okay. So 125 125 divided by 27 for what's the remainder for this one? Can you please help me? What's that? 4 times 27 is 108. If you take away 108 from 125, pardon? Excellent. 17, then 27 divided by 17. How many 17 do we have inside 27? Because, oh yeah. So 125 divided by 27 is 4 point something. So the quotient is 4, but remainder is like something that I asked you to find to get you guys involved. Okay. What's the quotient? 27 divided by 17. How many 17 do we have inside 27? Yeah, 1. What's the remainder? 10. No, yeah, 1 times 10 plus 7. 10 equal to 1 times 7 plus 3. 7 divided by, as long as I don't get remainder 0, I will continue. 7 divided by 3 is what? Will tell me. Plus 1, 2, and 3 divided by 1 times, sorry. 3 divided by 1 plus 0, which is 3. So the last non-zero remainder is the GCD of, so GCD of 125 is equal to 1. Now, does the equation what's that? 27x equal 5 mod 125 have solution? Yes, because 5 is divisible by GCD of 125, 27 equals 1. 5 is divisible by 1. So the congruence equation has got solution. Now, since 27, when the GCD is 1, we have easy time to find this x. If it's not 1, we have 2 strategy, but we can still solve it. If the right-hand side of this form of equation, ax equal b mod n, if b is not divisible by GCD of m and a, if it's not divisible by that, then the equation doesn't have solution. All right, thank you. Okay. Yes, please. Pardon? It's this one. Yeah. So in the computer science, which I teach to the computer people, they use usually this one, this algorithm. 125, 27. Okay, there is this theorem that they use. Okay, so 27, the GCD of 125, 27 is equal to 27 and 17. And you continue, so you choose the smallest number here, then 125. So this number remainder. Then for this one, 27 and 17, you will write 17 and the remainder 10. And you will get continue this one as long as you will get something like 1, 0. So the answer will be 1. You will continue this one as long as you will get 0 in one side. So this can be 1 or 5 or 2, anything else. Okay. So in this case, you get 0. So once you get 0, the other number will be the answer. Okay. In computer science, when we teach the for loop, while loop, quantifiers, so we teach this. Okay. So let's put this one aside. Okay. Now, 27x. So let's continue like somewhere else. I need this one. So why don't we write like this blue one here, blue version? Well, we need to do this one. We need to use this one. Also, 27x is equal to 5 mod m. From the number theory question for this week, this means 27x minus 5 equal km. Okay. So this means this one. So assume that we wanna find A such that when we times to 27x equal A times 5, this will be 1. Okay, so A times 5, so or like let's write it like 5 times A. So x equal to 5 times 8 will be our answer in mod m. Okay. All right. So from here, so pay attention, please. 1 GCD. Okay. Any GCD, again, another theorem I will not tell to you. If D is equal to the GCD, great common divisor of A, B, then there are ST belongs to Z integer such that A times S plus B times T equal D. We will use this one. Okay. Now, from here, 1 equal to 7 minus 2 times 3. From here, 7 minus 2 times, instead of 3, I will write 10 minus 7. Okay, 10 minus 1 times 7. From there, can we arrange this one? Minus 2 times 10, usually writing the bigger number first, plus there is -2, -2 times -1 is +2, and this one here, and therefore we will write 3 times 7. Now, using this one equals to -2 times 10 plus 3 times, instead of 7, I write 17 minus 1 times 10. Okay, so this means 3 times 17 will be minus 5 times 10. Now, back here, instead of 10, I will write 27 minus 1 times 17. 3 times 17 minus 5 times 27 minus 17. Rearranging minus 5 times 27. So again, so 3 times 17 minus 5 times minus 5. This will make us 5 and 3 plus 8 times 17. So this will be, can we use this one, please? Instead of 17, I will write 125 minus 4 times 27. Minus 527. We are about to finish this question, and I hope you understand. Instead of 17, I will write 125 minus 4 times 27 because of here. So, rearranging 8 times 125. Okay. And this one minus 5 and 8 times minus 4. So this means minus 32 and minus 5. It will be minus 37 times 27. Okay, which is equal 1. So we were successful to write that 1 is equal to 8 times 125 equal minus 37 times 27. This means minus 37 times 27 minus 1 equals to minus 8 times 125. This means minus 37, hello, times 27 is equal to 1 in the world of the mod 125. Do you understand this one, what I said? Like 125 here? Yeah? Is there any question? Which line? This one? This one? So I kept this term here and I brought this one to here, negative 1. And this guy goes to the other side, negative 8 times 125. Okay, from here, look at here. Now, back to the equation. (27x equal 5 mod 5). So we times start by negative 37. So negative 37 times 27 x equal negative 37. Huh? Say again. Excellent. Yes. Okay. So times it by 5. Mod 125. So this guy is according to minus 37 is what? Mod 125. So star 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 will be, oh, let's write becomes x equal to minus 37 times 5, please. Help. Yeah, yeah. Okay. Mod 125. Okay. In case of the asking one positive number, minus 185 plus 125 for that, it will be what number? 60, negative 60, plus another 125, positive 65. So at 125, at 125, at 125, yeah, x 65 mod 1, 2, 5. Yeah. Then any question about this? So it's not, there is no question about this. Question 2. Part B. 27x equals to 6. Okay. Mod 210. You guys, are you sure that you understood question 1? There is a YouTube link from me for question 1, part A. I will send those to you and today's recording as well. Exceptionally, today I record the class. So, I do question part B, so you will learn it. So, first step, GCD of 210, okay, 27. Let's use Euclidean algorithm. 110 divided by 27. Can any of you like use the calculator for me? 110 divided by 27. 7. All right. What is the remainder here? 7 times 27. 21 x. So now 27 divided by 21, please. 1 plus 6. 21 divided by 6. Yeah. 3 plus 3. Okay, 6 divided by 3 time plus, yeah, 0. So last remainder, non-zero, last non-zero remainder is, so is the answer GCD 210 GCD of and 27 is equal to 3. Okay, so in computer textbook, computer science textbook, they write like this: 210 27. The GCD of this one is equal to the GCD of the two ends. So choose the smaller number 27, and the remainder of that one, we just see that here 21. So 21, smaller number, remainder 6. Smaller number, remainder 3. Smaller number, remainder 0. So the answer will be 3. So in the computer science books, this happens. Now, this is the first case. The GCD was equal to 1. Now, we see now a case, a GCD equal, not equal 1. So in your quiz, question 3, you will have either GCD equal 1 or not 1. So when we have not 1, by the way, since what's the right hand side of the congruence equation here? 6, since 6 is divisible by 3, so the equation has solution. Okay, so that's important. Once we obtained the GCD, we should not try to proceed. We need to check something. So let's go back and do this one, 3. Here. So can I copy this one? (21) minus 3 times 6. 21 minus, can I use this one? 3 times 27 minus 21. Minus 3 times 27 plus minus 3 times minus 21. That's 3 of them and 1 another there. So here, times 21 equal. So I want to use this one. Minus 3 times 27. What's that? Plus 4 times minus 7 times 27, which is equal to 4 times 210 plus so there is -3 here, 4 times -7. 4 times -7 is -28. Why that minus 3 is to 31 times 27. Now, we were able to write the GCD of the 100 and 210 and 27 as the linear combination of them. But the equation is 27x equal to 6 mod. Okay. So we have that 6 equal to I times both sides by 2. 2 times 4 is 8. Negative 31. Yeah. Negative 31. Oh, sorry. Excellent. Thank you. Negative 31. You guys, what's happening there? Ladies, what's happening there? Do you listen? Are you with us or just like talking about other things? Okay. So 8 times 210 minus 2 times negative 31. 62 times 27. This means negative 62 times. Okay, so later minus 6. I moved to here. Okay. No, it's not working. Six plus 62 times 27 equal to 8 times 2010. 210. This is equal to like I really write like subtleties. I don't know why. 27 equal 8 times 210. This means, okay, A minus B, all of that, equal K times M. So A is congruent with B with mod M. So 6 equal to negative 62 times 27. Mod 125. So the equation was like 27x 6 mod 125. Okay. Uh, so x is equal to negative 62 mod 125. So negative 62 plus 125 is what? Sorry, why do I keep writing 125? 210 plus negative 62. 148 and yeah. So smallest positive integer for this one is negative 62 is the answer, but x positive smallest positive integer is 148. Mod 210. So this is the question one, part B. Part C. The last part. So I'm not sure the students how the students will be able to solve this question one, at least question one in the workshop. So what's the other? So 27 x 5 mod 210. The GCD of 210, comma 27. Do you remember from the part B? We can see that it is 3. Yeah, but 5 is not divisible by 3. So the equation doesn't have any solution. Okay. Is there any question about part one, part A, B, C? Okay. Any question? For next week, 21. This was just question one. Question one. So most of the students they won't be able even complete question one. But your in the quiz, your question one and question three will be about this. Finding GCD, and this quiz three, question three will be finding solution of the congruence equation. Last name called Abir. Acharya Isha. Acharya Isha. Next time, Acharya Isha. Next time you will sit here. Okay. Ayas Ryan. Daljit Kaur. Next time here with your friend. Yeah. Yeah. But the other two friends, they will sit separately. Yeah. Gauli Achana. So you will sit here. Yeah. Yeah. Hakim Mainur. Hakim Mainur. Hamid MD Yasin. Muhammad Ikramur. Istishat Zabran. MD Saqib Khan, you. So next time you will sit here, yeah? Because you had lots of conversation with your friend. Kumar Rohit, you came late. So let's keep it absence. MA Minku. MA, last name is MA, first name MA Minguyan. Say again. I wanna learn. Mingyuan. Yes. Mingyuan. Shawal. Muhammad Shawal. Mahsa bin Fatiha. You came late, yeah? You came late. Yeah? Okay. Okay. Marshali Rehman Hashim. Mashrafi bin Shuaib. Wait, Rinvi last name. Last year he was Sheikh Tahsan is here. Saifullah, Muhammad Saifullah. Is there any up there? Morning, people. So you came here, so thanks for coming. Is there anyone there? You want to know? Are you anyone there? So is there any friend there? Okay. Okay. Now, if you want to leave, just leave. Otherwise, I'm here to have your question. I did. Yeah, I did. Yeah, does. Oh, sure. What's your name? Don't come here. Yeah, Harmar. I said, but you were talking and you didn't hear me. Yeah. Okay, this time let's put it presence. For you, yes, but I noted that you came late because it's my responsibility. If something happens outside in the classroom, it's my responsibility. Right? Okay. Huh? No, nothing gonna happen. So wait. I will send the link.
Where I can get this?
I will send the email to people.
Everyone?
Yeah. So let me.